Hello everybody, welcome. Recently I faced a very interesting problem at work. We are refurbishing all the video conferencing rooms everywhere, and we were facing problems like you connect the equipment, there is no signal, USB connection not detected, especially when you use extensions, and the same problem happening with, for example, HDMI, right? Then we figured out that before doing a mass purchase of cabling and refurbishing hundreds of rooms, to then find that we have problems with specific resolutions or specific peripherals, we can actually get them all certified with this very interesting device I have here, the total phase cable tester. So it works in a very simple way. Here I have two testers. You take these test modules and you insert them in the cable tester, and they have a specific circuitry and logic to interpret electrically the cables, right? To make sure that it fulfills the electric specifications for the kind of data that you want to transmit through. And they are certified individually, so here mine are valid only until the end of this month, 3rd of April. And it works in a very easy way. Yeah, you get the module and you insert it into the cable tester to begin with. So for the sake of the example, I'm gonna now install the USB Type-C tester. So you just take it out of the bag. It doesn't come better protected than this. Then you line up the PCB with the rails here. And insert it, and you tighten the captive screws that are on both sides. And you're ready to go. Afterwards, if you already have a profile loaded, you don't need a computer to run the tests. You're gonna get the test result here. Otherwise, you have to go to the computer, load a profile, and of course you can use the computer to interpret the results. Yeah. On the back you have a few ports here. On the left hand side you have a normal mini USB port. This doesn't do anything except work as a virtual network interface. So when you connect to your computer, you get a generic USB Ethernet device with an IP address. You can log into the web browser. You get a LAN port, so you can work without a computer and log in from any computer in the same VLAN, in the same subnet. I don't know why I didn't manage to get this one working. Maybe I just don't have the license. Then here you get the IP address of the USB interface, serial number with part number, then you can connect a ground cable here, DC input, and the power switch. It's very well built, high quality. Now that I have everything connected to the computer, it's very easy. Yeah? I have the USB cable here going to the laptop. My laptop is connected to the charger, and I'll just power the device on. You see the LED here comes up, right? And soon enough, you see that I get the total phase platform connected on my laptop, and I get an IP address. And yes, it beeps. And you can see here that it's not running a test, but it's available. So now that we're ready to go, this is how the starting screen looks like. You can see here that the test is not ready because I have not selected a profile, right? So first thing I'm gonna do here is to load a profile. So I'm gonna click in change, and I'm gonna pick, let's say, auto detect USB Type-C cable, right? I'll save it. Now the tester is ready. You have more interesting information here. So for example, on the top right, you have the type of module that you have connected, and you can see that I've done 511 tests out of 10,000. And why this limit? First of all, the tester has to be recalibrated sometimes. And secondly, there is mechanical wear on the connector, right? That can make the connection a bit more loose. And the cable considers that. Now what I'm gonna do here is to connect the USB-C cable, and you're gonna see that the test will begin automatically. And on the screen of the device itself, you can see that autonomous operation would be possible. So I connect one end of the cable here, the second end here. A progress bar shows up on the device and also on the web browser. One interesting thing that I found with this tester is, for example, there is a difference when you flip the USB-C connector. It's a logically different connection. I thought the channels were duplicated or like crossed over, for example, so that's how you could invert it, but apparently not. There is a difference. And you can see I've just tested the USB-C cable that Apple sends with the device. And if you go to details, you can see that it is not a great cable. So, for example, the orientation detection here failed, and you can see how the pairs show up on the top of the screen there. And the electric characteristics are mostly good, except here on this pin that could even be short-circuited because you're getting like infinite resistance. Not sure how this works. And if you go down here, you can see that it failed even the most basic data integrity test. Yeah. But you get the marker detection and so on. You see the raw data of the marker didn't get to the tester the way it was expected. Yeah. I'm gonna flip the cable now for you to see the difference. Yeah, I'm gonna go back to main. And I'm not sure, but I think when I flip the cable, it will automatically run a test. No, it doesn't, so I'm gonna click on retest. As you can see now, the cable's been flipped, but you still don't get a proper test run. What I'm gonna do next is to change the module, and I'm gonna run a HDMI test for you to see the difference, because I have better HDMI cables than I have USB-C. You don't need to turn the unit off for changing the module, so you can disconnect the cable, and then all you have to do is to remove the module. The browser immediately complains that the tester has been removed, so the module I mean. And then the next step is to insert the next module here, lock it in, and the computer detects the new module. So the first step here for testing the HDMI cable is, of course, to load a profile. Right, so let's go for the highest one here, HDMI 2.1 with 48 gigabits per second and Ethernet. So we can save it. Now, once I plug the cable in, the test will start automatically. So as you can see, the cheap cable that I connected here actually works fine. Let's go to details. You can see here that all the plugs and the shell are connected where they should be. The electric resistance is within the parameters, right? And you can see here the data integrity is good in all speeds. And you can see that when you're sending only 1 gig per second, the tolerance is much higher because you see there is much less activity, right? So you see it's expecting a much more forgiving tolerance than the cable actually offers. But once you start, once you hit 12 gigabits, you can see that the margin of error is much smaller, but the cable still remains within the acceptable parameters. Now, what I would do at work then would be I would purchase from the same manufacturer 5 or 6 cables, right? And then I would, if they all would pass, then I would consider them approved. And we're going to do one more test with a different kind of connector. Now I'm going to test a USB-A 3.1 cable to USB-C, and let's see how it will perform. We start as always, inserting the module in the tester. And you see here that the tester now here has 2 ports to 1. And what happens is it's going to light up which port I should use based on physical wear. So it will count how many times I use each connector. And if I'm going beyond the specifications, then it will instruct me to use a different one. And let's choose a profile. So let's go do the standard USB 3.1A to USB-C. That's what this cable in theory is. We save. Now I can just connect the cable. You can see now there's a small light here indicating that this is the port I should use. So I'm going to just connect this here. And this here. And wait. And you can see my test failed. Let's see why. Grounding is not good. The ground pins have more resistance than they should have had. Yeah, in many instances the resistance is beyond the specification, which means that it would not pass signal. So, as you can see here, it was successful in 1 gig per second, right? But the 10 gig test failed. We can go back and try something else. So, let's go change here again, and let's try USB 2. Fails as well. We're going to try USB 2 then with a separate shield. It fails as well. So as you can see, electrically speaking, this may not be the best cable, right? It may work, but if you are very tight on the specification in terms of tolerance, then depending on the quality of the device in the chain of what you're using, you may have issues. Last thing I want to show you before we wrap up, settings, right? There's not much to go here. It will just give you the chance to update the firmware, right? Give you the serial number, how many times I inserted a module, because of course this will also wear the controls, and I already ran 1,279 tests on this tester. Yeah. Now that's pretty much it. I hope you enjoyed this video. This is super specific, but you guys following my channel are into very specific things, so there you go. Thanks for watching and I'll see you next time.